So yesterday I asked you guys to complete the square, and then I asked you guys to solve, which meant find x-intercepts. As we're remembering stuff because we will have cumulatives. This time I asked you to give me the equation. No matter what form I ask for the equation in, what do you have to put it into? Vertex form. So we know that we have -2 and -9 as our vertex, so we're going to label it P and Q. Then we can pick any other point. Often on a test they'll bold, so just pick whichever one it is. I'm going to pick 0 and -5. And then I'm going to label that my x and my y. So I get y equals a x minus a -2, so it's actually +2 squared plus.
Minus.
Yep, realize that after. -9. And then I need to plug in my x and my y because I have to solve for a, right? So you always have to solve for a because it's your vertical stretch factor. We always have to check for it. Also, you have to solve for a because sometimes it's concave down and your a needs to be negative, right? So we're going to go -5 equals a 0 plus 2 squared minus 9. We're going to add 9. I'm going to get 4 equals 4a divided by 4. And a equals 1. So you would have lucked out if you had not solved for a in this question, correct? And so we get y equals 1, or don't have to write anything, x plus 2 squared minus 9. Now we could type that into our calculator and see if they match. We agree? Yes. Yes? Okay. Now, what if I ask for it in standard form? You're going to have to, nope. Foil, expand. You're going to have to FOIL the x plus 2, you're going to write out twice, and then minus 9. Go. So we're going to write it as y equals, do we need to write the 1? We could. We don't have to. Yeah, so we're going to get x plus 2 times x plus 2 minus 9. Then we're going to get y equals x squared minus, or plus 2x is plus 4x. Times 2 is plus 4 minus 9. So we get y equals x squared plus 4x minus 5. And we can tell if we're right or not. Why? You can type them in and they should match. Also, what does the standard form give me? My y-intercept. What is the y-intercept? -5 is always the constant, the one without a variable. We agree? Okay. Now let's go to trig. So here it says, given the coordinate -6, -4, the first thing when you're given a coordinate you should do is what? Yep. So, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So I know I'm in quadrant 3, correct? Oops, I was doing so well and then it went downhill real fast. Okay. So I know I'm in quadrant 3. I know my answer should be between 180 and 270 when I do the standard position angle. Answer, if it's not, you did something wrong, right? That's why sketching it is so important. Sketching it makes it a little bit more understandable. Now, if I sketch it, I also can see that I have a triangle here, correct? So I take that triangle, and this can be my angle. I take that triangle off so it's easier for me to see it. I just do this. Here's my theta. Then here I have -4 as my y. My x I'm going to label as -6. I need to find my r. So I go r squared equals -6 squared plus -4 squared. R squared equals 36 plus 16. And what do we get? 52. Square root it, plus or minus. Don't forget the plus or minus. For r it's okay, but it won't be in the next lesson tomorrow. Plus or minus root 52. Root 52 breaks down into what and what? 4 and 13. The 4 comes out and it is a 2. So I'm going to get r equals 2 root 13. Why am I not taking away the negative sign? Because it can't be negative because it's a radius and radius is the length of measure. We agree? Okay, so we'll do the trig ratios first, then we'll come back to the angle and standard position. Pardon. So sine theta, sine your resume. So I'm going to get -4 over 2 root 13. Now I need to rationalize my denominator, so what am I going to have to do? Multiply by root 13. So I'm going to get negative 4 root 13 over 2 times, what's root 13 times root 13? 13. What's 2 times 13? 26. Once I have those figured out, now if I can cancel off the front of the 2, I do. I can take off a 2 out of both. So I'm going to get negative 2 over 13. So my answer for sine theta is negative 2 root 13 over 13.
Which part? Oh.
Okay. Cos theta is cook extra rice. So we're going to get negative 6 over 2 root 13. Once again, I need to rationalize, so I'm going to multiply by root 13. And I'm going to get negative 6 root 13 over 2 times 13 times 13 is, or root 13 times root 13 is 13. So 2 times 13 is 26. And then I reduce. Take a 2 out of both, I get negative 3 and 13. So I get negative 3 root 13 over 13. And then tan theta. Tan your x box. So I get negative 4 over negative 6. So tan theta reduces to 2 over 3. So that's if I ask you for the trig ratios. I also asked you for the angle and standard position. In order to get the angle and standard position, I need the what? Reference angle. And how do I get the reference angle? I take tan theta of what? Do we use negatives when we do tan? No. When we do the reference angle, we will always take the positive. We will always take the positive. We will always take the positive. So tan theta, tan your x box is negative 4 over negative 6. I don't care that they're negatives. I'm going to go 4 over 6. Then I'm going to go theta equals tan neg 1 of 4 over 6. And the reason why I take the positives is because it'll land me in quadrant 1. And if it lands me in quadrant 1, I get my reference angle. So whenever you're finding a reference angle using a trig ratio, you will always use a positive. Always, always, always. Next to your 2. It doesn't ever change. So if I go second tan of 4 over 6, what do I get? 34 degrees. So that's my reference angle. So that means this here is 34 degrees. So what is my standard position angle then? What is this? Yes, because what did you do, Chloe? So standard position. Theta equals 180 plus 34 degrees. Make sure you have degree symbols, which is 214. The next one, I gave you a little test. Can you draw 480? So we know that the whole circle, or the whole, if we go around once, it's how much? 360. And then I can just keep going, correct? Okay. So, if I go 480 minus 360, I'll know how much more it is than 360, correct? Which is 120. We agree? So it's 120 more than the full rotation, yes? So if I went to draw it, it would be rotating around here. I would go, boom, 360, and then what would I do? I keep going. This is 90, and then how much more would I go? 30 more. So it would end here. So you would do one full rotation, which would get me to 360. Then I do another 90, and another 30. And then I put an arrow. And why do I have to have an arrow? Because remember, if I don't have an arrow, I don't know which direction you're going. And if you go counterclockwise, it's positive. If you go clockwise, it's negative, right? So that's why you need that arrow. So you're showing that you're starting on your initial arm at 0, 0, or at the x-axis, positive x, and then you're rotating counterclockwise, which means it's a positive angle, which is 480 degrees. How do I get my reference angle? My reference angle is always from the terminal arm to the x-axis. So how much is that going to be? If this took me 30 to get to here, How much more to get to here? How much is this angle? Every single one of these are 90. We agree? Every single quadrant has 90 total. So if it took me 30 to get to here, how much is it going to take me to get to here? 60. So my reference angle equals 60 degrees. So it's between the terminal arm and the x-axis. Now we're doing mixed radicals. Mixed radicals means I need to have something outside, something underneath, and something underneath has to be reduced as low as it can go. Something underneath is called the radicand. So, and something in front is called the index. So I have 98. 98, what perfect square does it break down into, Leon? 49 and 2. If I take the 49 out, it becomes a 7. So we're going to get 7 root 2. Done. Hannah, 108. What does it break down into? 36 and 3. Do you see equal signs running down the side? Because each of these radicals equals each other, doesn't it? You should have equal signs. Make sure you have equal signs. If you don't have equal signs, you're going to go back and put equal signs. So we have 36 times 3. When I take the 36 out, Hannah, what is it? 2 times 6. You are correct. When there's more than one number in front, you multiply them. That is scary. Don't ever do that again, Tegan. 2 times 6. No, we're good. 2 times 6. Never listen to Nick Demideros. That will lead you to problems. It's literally like a clown, like a circus. Circus. You just stood on your chair. I think it's you. Okay, 375 cube root. Nick, what can 375 break down into for cube roots? Cube roots. Which would split it into perfect.
No, it's 20. No. 125? Yeah. Yeah.
Times?
3.
Yes.
Yeah, because I was looking at my answer. You know what I mean?
I said we got the same answer.
Okay, so you're not showing work. All right. So when we take the 125 out, Nick, what do we get?
15.
You get a 5, yep.
Yeah.
And then when you do 3 times 5, you get a,
15.
which is what you really wanted to answer,
I really want
really badly. And it's the cube root of 3. Okay, 216. James, what cube does 216 break down into?
6.
6.
Just 6.
Just 6. No. What cube can it break down into? He's trying to phone a friend. Someone gonna phone a friend and help him?
I did 27 and 8, but that also partial. Wait, I got 6. You did 36. I got 12. You did 36. I got 12.
Yeah, what's the cube root of 216?
6.
It is 6.
Oh.
I was asking what does it break down into?
Oh.
You just randomly say 6. It breaks down into 6 times 6 times 6,
Yeah.
correct? And when you cube root that, you get 6. Because the cube root of 216 is a perfect square, or perfect cube. And when you found out that both numbers were perfect cubes, that just means the whole thing is a perfect cube.
Yeah.
Just if that happens. So we're going to get 2 times 6, which is 12.
I did that.
Your explanation was minimal. That's the problem. Just 6. Done. Yes.
At least I got the answer.
James and Sam did really good on the beat test.
Good. Was it bad actually or good?
Sam won our class.
What?
Yeah.
Yeah.
Did you get new shoes, James, or are you still running with those?
No, I got new shoes.
Oh, that's why. That's
Yeah.
why.
Yeah. He was fast.
Yeah.
Yeah.
What if you had like real, like serious running shoes? How fast would you be? You'd beat Sam.
Too fast.
That's what would
Maybe.
happen.
Sam didn't even look tired. He just still like, he looked bored.
Birds.
Really? Yeah, he just looked like, okay.
All right.
What the heck?
So we have to order radicals. And you guys, this is also from grade 10 curriculum. So it's like a repeat. So reducing radicals, mixed radicals, entire radicals, and ordering radicals are all from grade 10 curriculum. They appear again in grade 11. The only way we can order radicals is to actually make them all be what? What do you think? Yeah, entire. You make them all be the entire radicals, you can compare them. Because if you have like 2 root 3 and 3 root 5, which one's bigger? I don't know. You could guess, 3 root 5 is going to get you a larger number, 2 root 3 is probably going to get you a smaller number because of the numbers they are, but it's kind of hard to guesstimate that way, right? But if I give you root 16 and root 25, which one's bigger? Root 25. It's way easier if you have entire radicals. We agree? So whenever you're asked to order, you're going to turn them into entire radicals. So, can I take a negative and put it under a square root symbol? No. Can I take the 2 and put it under? Yes. I'm going to leave the negative outside, and immediately the negatives are smaller than the positives because they're going to fall in the number line in the lower section, right? They're below 0. Okay? So this one, if I want to take it inside, I'm going to get negative square root what? How do I take the 2 in? We did this yesterday. Yeah, so you go 2 squared, you times by itself, and then bring it inside. So 2 squared is 4 times 3, which is 12. And then we have root 50. It's done already. Yay. Thank you. And then we have negative root 14. It's done. Yay. And then we have 3 squared root 3 root 5. What's it going to be? 3 times 2 is 9, times 5 is 45. So if I order those on a number line, I would have 0 here. 14 is bigger than 12. We agree? So it's negative, so it's actually going to be smaller, right? Because it'd be more left on the number line. So I would have here negative root 14, negative root 12, root 45, and then root 50.
Did you not put the
Yes, exactly. So when everyone goes to order this, they will tell me, so I just put it on the number line like this, but they'll tell me that they order it and they'll say negative root 14, negative root 12, 45, and 50. Except those are not what the original was, correct? You have to order the original numbers. So I'm going to write them on the number line like this, because that's just the number line. I'm not ordering anything, correct? But now I need to order the actual numbers that it was. So negative root 14 was actually negative root 14. We agree? So I can go negative root 14, comma. Negative root 12, I'm not going to write as negative root 12 because it was actually negative 2 root 3. Then I have to do root 45. Root 45 wasn't actually root 45 though. It was 3 root 5. And then root 50 was root 50. Boom. I ordered it and I'm done. So that's exactly right, Ted. You have to make sure that you guys order the original numbers, not what you just came up with. But you use what you came up with to order. Okay, you guys are trying the next one. So root 18, root 2, this one's going to be root what? 6 squared, drop it underneath, times 2 is 72. So if I ordered these, I would have root 2, root 18, root 32, root 72. And so when I actually order them, I get root 2, comma root 18, comma root 32, comma 62. All right. Now we're going to do adding and subtracting. So just like actual polynomials, you have to have the same like terms in order to collect them. So say I have 2x plus 6, I'm done, right? But if I had 2x plus 4x plus 6, I would say 6x plus 6. I would put together the like terms. We agree? Radicals follow the exact same rules as polynomials. So you can only put together radicals that have the same radicand. So like x and x, I can only put together. Number and number, I can only put together. Y and y's, I can put together. X squareds, I can put together. Correct? Radicals are the same thing. Root 11, I can put them together. And then they follow the same rules as polynomials. So if I had 2x plus 6x, I would have 8x, right? If I had 2 root 11 plus 6 root 11, I'd have 8 root 11s. It's the same, follows the same rules as polynomials. Okay? So let's look at these first ones. It says simplify each expression. I have 7 root 11 plus 3 root 11, or minus 3 root 11, plus 8 root 11. So I can actually put them all together because they're all like terms. If you imagine this as 7x minus 3x plus 8x, what would I get? 12x, correct? But x actually is root 11, right? So we're going to get 12 root 11. 7 root 11 minus 3 root 11 plus 8 root 11. So if you think about it as root 11s as just x's, it'll make your life easier. And then we're done, and we have an equal sign because these are the same. Now, could I check these? Because they're all numbers. I could. I could go 7 root 11 minus 3 root 11 plus 8 root 11, hit enter, it'll give me a decimal. Correct? And then I could go 12 root 11, it'll give me a decimal. And what should those decimals be? Equal, because you just said this equals this. Correct? So it's all numbers. You can turn to decimals. Check. Okay, let's look at this one. We have 4 root 3x minus 4 root 2 plus 1 root 3x minus 1 root 2. It's better to put 1s there. Sometimes it's helpful. So I'm not going to be able to make one term because they're not all like terms. Correct? But some of them are alike. So I have 4 root 3x plus 1 more root 3x. How many root 3x's do I have? 4 plus 1 is 5. Thank you. Root 3x. I was scared for a second there. It really came back from the sadness. Okay, minus 4 root 2, minus 1 more root 2. How many root 2's do I have? I have, yeah, minus 5 root 2. So where you're going to get burned in these is if you can't do integers, adding, subtracting of integers. So like minus 4 minus 1 more is minus 5. That's going to burn you. Or if you can't reduce radicals. Right now we haven't had to, but we will soon. Okay, I'm going to get you guys to do B and the try. So here we have 9 root 6 minus 1 root 6. How many root 6's do we have? 8 root 6. Whenever you're simplifying, there's going to be this equals this, correct? If the equation has an equal sign in it, you're just going to rewrite the equal sign where it exists in the equation, correct? If it says simplify and there's no equal sign, it always runs down the left. Always, always, always. It doesn't change no matter what math class you're in. Then we do 12 plus 4 is 16. Done. This one, we're going to do 6 root 5 plus 4 root 5, which is 10 root 5s. And then minus 1 root 7 minus 3 more root 7s, and I get negative 4 root 7y. Okay, then we're going to flip over. It's not going to stay this easy, obviously.
Why? Why can't math be fun?
It is fun. So all we're going to do, these questions don't get crazy. If you can reduce a radical, these questions will stay easy. Because all you have to do is reduce a radical. This is not like, these are not hardcore questions. This is like the nicest, easiest lessons. If you can reduce radicals. Remember I told you if you can't reduce radicals, this lesson's going to be hard? It will be. These are not like radicals right now, are they? But can I reduce 20 and 40? 5? That's not a 40? Yes. Okay, so if I'm going to reduce this, I have to reduce them first. So I'm going to go equals 3 square root. That d is staying for life, isn't it? Because it's a square root, I need 2 d's in order to take out a d, right? It's a 2 for 1 on variables, correct? If it was a cube root, I'd have to have 3 for 1 to take out the variable, correct? It has 1 d, it's not going anywhere. That d is staying. But the 20 I can break down into what and what? 4 and 5. So I go 4 times 5 times d. The 4 comes out and it is a 2. So my next step I'm going to have 6 square root 5d. Then I go to do the next one. I have a 5. 45 can break down into what? 9 and 5, and then we have a d. 9 times 5 times d. The 9 comes out and it's a 3. And then I get what? 15 square root 5d.
Whoa.
Do you see why you put those numbers together in the front? We were talking about that yesterday. You always put them together as multiplication because now what are we going to do? Collect like terms because they are like. So what? Since now we're just at the previous questions. So once we reduce a radical, we're just doing the easy questions like we were on the previous page. So what's 6 plus 15? Root 5d. You do the try. Root 10e, does it break down at all? No. So we write root 10e. What about 90? 9 and 10 and e, the 9 comes out and it's a 3. So we're going to get root 10e minus 3 root 10e. And then the last one I can take out a 4 and a 10. 4 comes out, it becomes a 2. And what do I do with these two numbers? Times them. So I get 8 root 10e. And so I have 1 minus 3 plus 8 is 6 root 10e. D. I have 5 root 3 plus root 12 minus 48 root 48 plus 2 root 75. 5 root 3 can't reduce. Root 12 can break down into 4 and 3. The 4 comes out and it's a 2. 48 breaks down into 16 and 3. Yeah, 16 comes out and it's a 4. And then 75 breaks down into 25 and 3. The 25 comes out and it's a 5. So I'm going to get 5 root 3 plus 2 root 3 minus 4 root 3 plus 10 root 3. And that's going to be 15, 16, 17 minus 4 is 13 root 3. Then I have root 63. Root 63 breaks down into 9 and 7. The 9 comes out and it's a 3. 75 breaks down into 25 and 3. The 25 comes out and it's a 5. 28 breaks down into 4 and 7. The 4 comes out and it's a 2, and then I'm going to multiply. And the 27 breaks down into 9 and 3. The 9 comes out and it's a 3, multiply. So I'm going to get 3 root 7 plus 5 root 3 minus 4 root 7 minus 9 root 3. Can I put them all together? No, but I can collect some of them, right? So I'm going to get 3 root 7 minus 4 root 7 is negative 1 root 7. And then 5 root 3 minus 9 root 3 is negative 4 root 3. Your homework is page 279. Oh, the whining. Numbers 6, AB, 8, 9, A to C, 10, A to C.